Greetings, Gen Chem people. This is going to be a video demonstration of Part B of your online gas pressure lab, and Part B is called the atmospheric pressure. So we're going to be examining the pressure exerted by the gas that makes up the atmosphere that we walk around in or is submerged in every day. And that atmospheric pressure, just like any gas pressure, is due to the collision of these really tiny little particles of gas, of nitrogen and oxygen, moving at very high speeds, colliding with surfaces. The surface of your skin, the walls, and whatever is in contact with the air. Now, the number of these collisions is so enormous, unbelievably huge, that when you add up all the force of all these collisions, this ridiculously large number of collisions, you get a significant force and a significant pressure. And it turns out that the atmospheric pressure produces about 14.9, almost 15 pounds of force for every square inch. A square inch would be about that, like this, an inch high, an inch wide, and about 15 pounds of force is pushed upon on every square inch area from these collisions from the atmosphere. Now, what does 15 pounds of force look like? 14.9 pounds. Well, this would not be 14.9 pounds. That's only about 5 pounds. This would not be 15 pounds or 14.9 pounds. This would only be about 10. And put that one there. And now we're about 14.9 pounds. That is a lot of force. And imagine every square inch area of your body, every square inch area of anything in contact with the atmosphere is being pushed upon with that magnitude of force. And if you take all the square inch areas of this can and multiply it times 14.9 pounds per square inch, you get a huge force pushing in on this can from the atmosphere, on the order of 500 to 1,000 pounds of force pushing in. Now, the reason the can does not collapse is because there's air inside that's pushing back with exactly the same force, the same pressure. And so it's in equilibrium, and we don't see any change. However, what if we were to remove the gas inside the can? Then we'd have 500 to 1,000 pounds pushing in with nothing pushing back out, and the can would collapse. It should go to something like this. Okay? Now, I'm saying 500 to 1,000 pounds is the force pushing in on this can. I'm not giving you the exact pressure or force because you need to calculate that as required in your lab protocol. So read that and do that calculation and report it in your lab report. So what we're going to do is remove the air from the inside of the can and crush it from the with the atmosphere. And the way we're going to do that is put a little bit of water in the can, maybe about 10 mils, not much more than that. It doesn't have to be exactly that, 2 or 3 tablespoons of water. Put it on a source of heat, like a stove. Let it sit there for about 3 or 4 minutes. It'll boil. Let it boil for a while, a couple of minutes. And then get a pair of gloves because it's going to be hot. You're going to pick it up and invert it into a container of water. Make sure that the open end is what goes in first into the ice water. So I'm going to turn this off. I'm going to pick this up, put it in there, and voila, we have our crushed can. Now, you may not think that's very impressive because anyone can crush an aluminum can, pop can, with one hand, or 2 hands. But I don't think there's anyone in the class or anyone I've ever known that could crush a 55-gallon steel drum with their bare arms, legs, or hands, or anything else. And that's what you'll see being done in another video, demonstration video, that's for which the link is given in your protocol. And you'll take a look at that and you'll see a 55-gallon drum collapse. And it'll have, because it's a larger surface, it'll have more area, it'll have more force pushing in on it, and so watch that.